All right, so let's get started with the agenda for this evening. We're going to look at protocols and categories. We looked at protocols last time, so I want to refresh your memories because we're not going to build it. I'm going to show you what it is by looking at a project that's already built. Then we'll build a category project next that encompasses the same concept. It's just done slightly differently, and I'll show you both at the same time. And if you want, you can build a protocol along with your category in the same project. And because this is the Objective-C course, we'll be doing a non-iOS app to start out with. Instead, we'll be doing a Mac OS X application as well. And it will also reinforce the idea of adding classes and stuff to your projects. So working from a base project. We also have, if you're sticking around later for the iOS course, we'll be looking at data this evening. So that's on the agenda. All right, so this protocols example is in the lecture. Let me just show you real quick where to get it. It's from bhacker.com, and it is from the Spring 2013 Object-Oriented Programming in Objective-C. And under source code examples, it is located in the lecture for examples, I believe. Let me just make sure, actually. There's also programming examples. Let's try this one, practice number 2. It's either going to be in that one or it's going to be in this one. And if you're curious, you can download them both and see what's inside of them. If I open up the programming examples, I think that's the one it's actually inside of. I see, no, I don't see that. Let's see. Let me try this one real quick. I probably should have found it and labeled it first, but let's see. Here it is. It was in the one I thought. So it is in lecture 4, which was the lecture we did last time, or the 4th week of class. This is the 5th week. So it was in lecture 4. And protocols is the example you're interested in doing. So you double click on the file after you've loaded it up. Double click on the project file and bring it up inside of Xcode. And let me show you what a protocol is. Talk about protocols for a few minutes just to refresh your memory, because it has been a week since we looked at the lecture part of this.
Oh, by the way, is
yes?
Snow Leopard okay?
No, Snow Leopard's not okay.
Fine.
In order to get Xcode installed on your computer, you're going to have Lion or Mountain Lion. The other choice for Snow, there's no other choice for Snow Leopard, I'm sorry. Unfortunately, you'll have to upgrade your OS. If you have 2 gigs of RAM or more on your, what do you have?
Mac Air.
Mac Air should work. If you have, the Mac Airs came with 2 gigs and 4 gigs. If you have the 4 gig model, you're in pretty good shape. If you have the 2 gig, it'll still run. Xcode will run slow. Mountain Lion will run faster than your Snow Leopard. So you'll upgrade. Okay. All right. So we're looking at the example called protocols, and the protocol that we're looking at is called printing.h, and we know it's a protocol because of the @ protocol in the declaration file. So how did we get this one in here? And before I talk about what it is, I'm going to say how did it end up in here. This is just a normal project using inheritance. We actually saw this project in week 2 when we looked at inheritance. We have a fraction, and then we have a complex number, if you remember the example. Same example, actually. And in main, we're making some instances of the fraction and the complex number, and we're going to run some things on it. What does a protocol do? It makes some consistency. Well, protocol stands for rules. It adds some consistency, or actually, if you're familiar with Java, it's very similar to an interface. It provides an interface to multiple different objects to make them all the same. That's number 1. Number 2, give them all the same behavior in terms of having the same functions or the same methods that can be run without having to determine what kind of object it is. And then if we make a generic ID, as we have in this example here, we can use this generic thing that abides by the protocol here that we're using, printing, and use it sort of like a generic object, but know what's inside of it because it's abiding by this contract that's part of the protocol. So how do we get this protocol into this project? We just created a brand new project. And you go to File, New, File. So if you're in the project window, you're adding it to the project. And in this particular case, this is an OS X or Cocoa Touch. It doesn't really matter which one. We actually have them under both. This is I believe that this is a terminal program. So I'm going to go under Coca over here, and we see Objective-C protocol. We also see a category. I'm gonna go through the process of adding a category next, but it's done the same way. So kind of basically just showing you where this comes from. We added this to the file with the protocol. In fact, I'll just put a protocol in here. I'm just going to call this test. This is kind of like what I did last time, actually. This is sort of a review to get us up to the same speed here. And I'm going to put it in the same folder as the rest of the project. And now I see, oops, here it is here. I have this protocol here called test. And it's just basically a .h file. It's an it's an interface file, no implementation. So we're familiar right now with the .h, I hope, and the .m at this point, because now we're approaching intermediate level knowledge here. So in the beginning we learned about the two files that are associated with the objects, the interface and the implementation. Now we're just adding another interface, which is this protocol, as we're calling it, that's going to have some methods in it. And then we're going to implement those methods in other classes, as many classes as we want, actually. And we tell the class that it's abiding by this protocol. We have optional and we have required methods that we can implement. If we leave off the optional required stuff, everything's required, which is sort of like the way you would do it by default. So in terms of the construction of it, looks pretty simple. It looks like this. You know, we have at protocol, because it's not an interface. And it's not an implementation, it's called a protocol. And this one is extending NSObject because we're writing a regular Coca application. So it's kind of the format. For if I go up and look at the one here, printing.h, it's another protocol, but this one's more documented actually. And this one's called printing, and we have one method in here called print. And then I have an interface that's basically in here called printing. And in the printing method, it's extending NSObject, and there's nothing in here. It's just basically blank. This actually doesn't have to be in here. We could take this out. We're not really looking at that. What we're looking at is the implementation. In fact, that can come out, but the implementation of the protocol is what we're primarily interested in here. And knowing that we have a print method in that protocol is what we're interested in. Why we want that? Because if we make a class and we say it's going to use this protocol, then it has to, because we left out optional and required, and it's at optional, at required, which is going to give us that kind of those options. We know that we're going to have a print method in here, so the protocol for the interface, not to be confused with the other interfaces in this file, defines a single method print. And I believe, let me just undo this typing here. This you can stay. It's basically just the original. It's the original code that was in the file to begin with. So if you mention, look over here. I have a protocol. Actually, the template changed between the two versions. This was actually created in an older version of Xcode, so it looks like the current version is taking out that information. So all we need is the at protocol and the at end to define our protocol. So in here, this is our protocol right here. This is just garbage. We can leave that out. So how is this used? Well, let's take a look at the fraction. And in the fraction is going to be using the printing protocol. This is the key right here. So we put the word printing, which is the name of our protocol, inside of opening and closing brackets here. And then we have the interface fraction that is using, same as before. This is the same as we get when we create the template for a new class. It's extending NSObject in terms of its inheritance. It implements the printing protocol to sort of use Java terminology, because some people are familiar with extends and implements. But that's essentially what we're doing, is we're using this notation. What do we have for a fraction? We have a numerator and a denominator. And then what else do we have? We have integer with numerator. This is initializer, as we've already discussed in this course. To initialize an object, we can initialize it with two parameters. We're going to initialize it with a numerator and a denominator. And then notice, though, I have no print method in here, because the interface for the print method is in printing. And so we don't have to actually include a method prototype for that. We've included it already when we say we're going to implement printing. So in the .m file, lo and behold, on the bottom we have this print method. And this print method is, where did that come from? Well, it's because we're abiding by that protocol. And you notice we didn't mention anything, we're just implementation of fraction. So in the fraction.h file, we've imported printing.h. We've implemented printing with this line of code here. So this is the key here. These two lines are telling us that this file is going to use protocol. And then over here, we just pretend that printing was part of the original methods that we implemented or put in the interface. And now we're going to implement them. So down here on the bottom, we're going to print the numerator and the denominator of the fraction. Now, we've done the same thing over here with complex. Same as before. Imported printing.h using the printing protocol and no redeclaration of the print method. Instead, in the complex, we're going to use complex here to print out the real and the imaginary part of the two numbers that we've got. And we have a real and imaginary. And they're synthesized, they're property and synthesized in this example. And they're synthesized with the underscore. We get this automatically, actually, if we don't synthesize. And I'm going to show you that in one of my examples tonight, actually. Yes?
If we define an interface, can we still implement, we can inherit from another interface?
Yes, we can inherit protocols from protocols.
No, from the interface.
From the interface?
Yeah,
Of course.
Yeah, from one interface to another.
Yes.
It works same as protocol.
Yep, works the same way, actually. So let's see, in the .m file here is our implementation. I'm not going to go through the implementation. We actually have seen this example, sort of a review of something we've already looked at, but I wanted to refresh your memories on that. The big part of this example and the part you really want to remember is we've imported fraction and complex, and then out in main, I've created an instance of the fraction object, called it frac, an instance of the, and let me make this real estate a little bit bigger here, an instance of the complex number, called it comp, running the initializer. This should look hopefully very familiar to you at this point. And then here we just created a generic ID, and the ID is called printable, and it's abiding by, again, the printing protocol. So whenever you see protocols, you're going to see these brackets here around the word, and that's going to tell you it's a protocol, hopefully, eventually after you look at it. And all examples look the same, so it's going to definitely stand out in a while. What do we do? As I said, this is a generic object that abides by printing, so everybody that abides by printing has the print method in it. So if we said here, this is the name of our ID, printable fact equals fact, and then printable print, running the print method. Hopefully this looks familiar to you at this point. And it's going to basically print out the fraction. And then down here we have printable is equal to the complex number we created. And then this is just a little thing for the screen. And now we're printing out the complex number. And then printable print. Well, printable, we're repeating the printable, but the printable is the generic ID, follows the protocol. If this follows the protocol and these guys follow the protocol, the generic type works, and we can assign one to another because they're all of the same family. What we did is we took, instead of inheriting and using inheritance as a mechanism to include and extend behavior, instead we used something to grab them all together and put them all on the same, make them all the same. Everything that abides by printable, for the printable purposes, for the protocol purposes, abides by the same rules. So what you can do is have a generic, as an example, print, in this case, print a fraction out like a fraction should be printed, print a complex number out like a complex number should be printed. It's been assigned to a generic ID. We don't know which one it is, really. All we know is what is being printed out. This is sort of equivalent to the, well, from C++, from a virtual method, if you're familiar with that concept. It's kind of like delayed binding on a method invocation using an interface. So it's kind of a combination of Java and C++ in concept. Did you have a question? Or?
I didn't understand the ID part of it. The printable is of type printable, right?
The printable is an ID type. It's not a complex number and it's not a fraction. It's a generic. In fact, we can create other things here by using ID. Yep, my data. And I've created another one. I haven't used it yet. It's going to tell me I've initialized it, but unused. Yes, of course, I just created it. And then I can have my data equal to something. It's a generic object reference type. Covered that one a couple weeks ago, but you might not have remembered actually. So ID is basically generic, which is similar to the pointer actually. So we can create a pointer in other languages. Actually, we can create a pointer in this language as well, and have the pointer assigned to any reference that we want essentially. So ID is generic. Don't always have generic references in a lot of languages, but we have one in Objective-C. And if we run it, it's going to run on a command prompt here. So on the bottom of the screen, we should hopefully see some interesting output. This is a fraction is 3/4 and a complex number is something else. So it's going to have our imaginary and our real number printed out here in the format that we gave it. And the print method is going to be chosen for the type of object given a generic ID, which is printable. But inside of this object dynamically, we've created its print method that abided by the protocol. And we know that print's in there, so this command is not going to fail on us. If we have one that doesn't abide by that, it's going to fail. In fact, if I go like, ID, my ID, and then come down here, my ID, doesn't abide by the print protocol. It's going to work. In fact, this should actually, it doesn't abide by the printable protocol, and it still does work. But this is going to tag the object. This isn't tagged, so if I ask the object what it was, it's not going to come back and tell me it's printable. So they both kind of, this is the concept of the ID, by the way, as well. It's kind of a generic type, and I can assign the generic type to anything, instead of treating it like a fraction or a complex object type, which is when I do this, because I've allocated a fraction, so fraction alloc, to this reference for the fraction. Here I didn't do that at all, I just created a generic type. Common to see generic types when you're working with a bunch of different objects of different types. And then if you want to ask the object what it is, and then if you tag a protocol on there, you can say, oh, it's printable. So printing, it abides by the printing. So people do this also for tagging, which is the same thing you do for, in Java, you can do an interface for tagging objects. You can say integer ID, dinosaur. And then every one of the dinosaurs that's been inherited from that, you can always ask for the ID. It comes back and says, hey, I'm a dinosaur. It's kind of a cheat sheet way of leaving a cookie behind, on the object. Because once I've changed it out of here, how do I know that how do I know my ID here was a fraction? May not know that, especially if I stuck them in an array. I use the array for something, and then how am I going to know what it is? Well, then I can check for a variable that's in the prototype, or I could check for is a relationship, or is this an object instance of, and then I can figure out what it is. So, questions on prototypes? No? Well, dwell on the concept. At least if you should walk away, hopefully, with the concept of what it is. You'll see what it is compared to categories, which is what we're going to do next. So now if you have a computer and you want to participate, here's your opportunity. We're going to do a category example. This one's, let me make this a little bit bigger here. This one's called reversing a string. So it's also going to enforce some of our Objective-C code. Show you how to basically put together another project, just in case you need more examples. Why convert? Well, this is going to basically take and reverse a string. But we have to convert the string because we're going to have a string. We're going to convert it to something. We're going to change it around. We're going to manipulate it. Sometimes we want to perform some task on an object that's not included in the methods of that particular class, and it's generic. It's a generic method that we're going to create. And this is why I say now we're kind of branching into the intermediate kind of level, because we're moving outside of objects. Hopefully you know how to create an object, you know how to put methods inside of an object. Now let's just create some generic behavior that we can just extend on strings, or we can add a complement. This is where we're going to get our plus instead of our minus in front of that method, as an example, to create class level stuff, or just to create categories is what we're going to do here. So sometimes you want to perform some task. Example might be to reverse the order of a string of characters in a string object. While you could certainly do this in the code, it would be better if you added a class method. And what am I going to add the class method to? In a string. So it's not overloading, it's not overriding, it's supplementing. Adding your own method to a class that already exists by putting it in a category and including the category. So now NSStrings knows how to reverse itself. So any object that is of type NSString has this method associated with it in the context of how you're going to use it, which is what we're going to accomplish here. Different than a protocol. Protocol is added to classes supplemental to the interface and the implementation. It creates unique implementations of the same interface in multiple classes. This one gives you a new method that overrides, not overrides, complements. I don't want to use the word overriding or overloading in this context, but it adds another method, adds another class that adds another enhances. That's a good way of putting it. We'll see how that works. We're going to add a method to reverse any string. We'll work on any string. So we're going to use a category to add the string reversal method to NSString. So we're going to extend NSString behavior by adding another method. And so once we have added that and have included the category, then all the strings we use will have access to that method. So category is an Objective-C construct, allows you to add methods to any class regardless of whether or not you have the source code for that class. When we don't have the source code for NSString, we're not touching NSString. We could do the same thing. We can overload, complement, enhance NS integer, or any of the other NS objects as well the same way. Once we add the category to the class, all methods in the category are added to all instances of the class in the code. All strings, regardless of where the string occurs, will abide by this category. Since categories are maintained in separate files, simple matter of including them in any project where you want to extend the features. And again, you know, another reason why to separate stuff out. I often see, very often actually, in fact I just saw it today, not going to point out the student, but everything all in one file. It's great for learning purposes, but eventually further down the road, if you put the category in don't put it in a separate file, just include it in everything else, you're not going to have that functionality available to you to quickly add to another project. So the more you can separate stuff out, although the language, you can put everything all in one file, the more you separate things out, the more reusable the code is further down the road. So let's open up a new single view application. So start Xcode, create a new application, select the single view option, template, and then click on next. We're going to select the use auto reference counting, and don't select the storyboard, don't really need it for this application. And we're going to add a text field and a UI label. It's going to look like that. So let's get that far. That's pretty generic. Just a text field and a UI label. Alright, so going into Xcode, this should be hopefully very familiar to you at this point. Create a new Xcode project. And what am I going to do? Am I going to create, hold on one second, let me just refresh my memory on what kind of project I'm going to create here. Single view application template. I'm going to create an iOS application for this. It's not going to be a DOS console, obviously. If I just looked at the window, that would give me a big red flag right there. But I could create a window in a non-iOS project, by the way. And we're going to see that not next week, but the following week. We create window-based NS windows and stuff inside of applications that are not iOS applications. But anyway, let's go back to Xcode here. And I'm going to go into the iOS section. I'm going to go into application, and I'm going to go into single view application. You guys are probably farther ahead than I am. And I'm going to call this one the category. Category, if I can spell it. And it's going to be an iPhone. I'm not going to use the storyboard, but I'm going to use the automatic reference counting. You can use the storyboard. It doesn't really matter at this point, because you can probably navigate with or without the storyboard. The instructions, however, are going to be just for the window. So I'm going to press next. And I'm going to save it on my desktop so I can get rid of it later. So this is part where I was telling you, if you have a computer, it makes it more interactive. Anyway, you probably catch it. Alright, so we're going to click on the Xib file. And I'm going to make a little window that looks like that one, although I'm going to make my background green instead of yellow probably. I always like to change the backgrounds on this. So hopefully we've gotten this far. We don't have to change the background, but I do it anyway. I don't know, it makes it more personalized. I'm going to drag over a label. Where was my label? In a text box, I believe. The label's I'm going to leave something on my label so I can tell it's where it's at, and I'm going to put a text box above it. The problem with not leaving something on the label is you can't tell how big it is. I wanted to make it as big as the text string, otherwise it's going to overflow. And I can center the text here if I want to as well, which is what I just did a few minutes ago. I'm going to put here reversed string. So that's where my reverse string is going to go. I think I'll raise the fonts a little bit. Go ahead, play around with your interface. Get it to look the way you want. And go ahead and put a text box up there next. And this text box I'm going to have span the entire area. So naturally you can possibly see what's going to go on. The user's going to type something in the text box. I'm also going to show you again the resign first responder to get rid of the text, because a lot of people are still having problems getting rid of text boxes, or getting rid of keyboards on interfaces with text boxes. And then the reverse string is going to end up here. So we've spent days and hours and we have a beautiful interface. Now we're going to make it do something. So let's go back to our tutorial and see what it is we're going to have this thing do. Set the UI text field's return button type to done, because we're going to implement that first responder. I'll talk about that in a few minutes. And it's in the attribute inspector. They don't really call that anymore. This is an old tutorial. In the fourth button down, there's a return key towards the bottom of the screen. What does that mean? If we click on this text button over here, we go down here, this is what's called the attribute inspector. If you put your mouse over here, the little thing comes up. It says show the attributes inspector. A little bubble of help shows up. But down here on the bottom it says return type. We're going to change that one to done. Believe it or not, we don't have to do this anymore. It automatically, that's like an extra step you don't have to do anymore. This is a old 4-point-something or 3-point-something Xcode tutorial. So some of the instructions are a little bit different. But it's okay. No harm, no foul. So we'll change it. Because if you're working on a previous version of Xcode, you might actually have to just probably know that done only says an event from the returns on done. Return T is done. Alright, now we're going to add one of those categories in there. So we're going to hit the iOS Cocoa Touch, and we're going to hit the Objective-C category. We're going to add a new category, and we're going to name the category Added Methods. Make sure that the category is on NSString. So the box looks like this, and we're going to call it Added Methods. So let's open it up, see if we have any brand new objects here. And now I'm going to click. I could stick it here, and this is going to end up in my outer directory, or I could click on category. Wherever you click here is where the file is going to show up. I'm going to stick it inside of the folder with the rest of my files. I'm going to go File, New, File. And up here, make sure you got this, because you have both options available in both sections. I want to make sure I have the Cocoa Touch. Keep flipping back and forth between touch and non-touch, which is why I have to do it. Yours is probably already hopefully selected. Objective-C category. Next. And it now says NSObject. So make sure we change that one to NSString. I probably could have typed it in. There it is. And now added methods, is that what we called it? Let me just make sure. Added methods, there we go. Click on the next, and then we're going to have two files that are going to show up. They're going to be called nsstring.addedmethods.h and nsstring.addedmethods.m. So let's take a look here. I have to click on next. Save it. I'm going to save it here in my category directory, and here are my two supporting files. So it actually put it in the supporting files subdirectory, which is kind of interesting. I was kind of curious where it would put it. In the old days, it just put it wherever you wanted it, wherever you clicked on it. So now you should have two files if you've done this correctly, which is kind of interesting. So it's NSString plus these added methods. So it's going to be NSString plus whatever you called the class. And you're going to get NSObject plus NSInteger plus, depending upon what you're extending from or what we're inheriting from. We're inheriting from string. So it looks like any other one, except for we've got this in here. It says added methods. That is of NSString. So we're adding to the NSString class. And we're adding something that we're going to be calling under added methods, which is kind of interesting. So this is the interface NSString, and then this is the implementation for NSString, which is kind of interesting if you think about it in terms of what it's trying to accomplish. So the file naming convention makes it easy to see the categories as you've added them. Hopefully we have that in there. Now let's see, open up the .h file, because you know we always start with the .h file and interface, and then we add the implementation after we've put the interface in. And we're going to add the declaration for our new class method here, and as shown here, which is going to be string by reverse string. String by reversing string. So we're going to produce a string, and what I'm going to do is I'm going to cut and paste this. Copy and paste it, how's that? And I'm going to put it in the .h file, so make sure you get the .h file open. And this is nothing more than another method prototype. Hopefully you haven't gotten any error messages. And notice a big thing here, we have the plus. All of the methods we've been creating to date have been minuses because they're methods that are run from instances. So inside of each one of the instances, we have these methods that are accessible by the instances. And they're all public by default. And interesting thing, I changed the assignment. Somebody had pointed out again, assignment number 1 says create 2 public and 1 private. There's no such thing as a private method inside of an instance. Doesn't work. However, what you should have had after this lecture, you don't have to do it. I took it out of the assignment description. I just removed that line. If you did do it, or if you want to do it, you use the plus. If you put a plus inside of the method, inside of any object that you're creating, it's not accessible. It's private, not accessible by the object instance. And you're wondering, well, why would you want to do that? Have no idea. Very limited use, but a private method that's not accessible by main can be run from inside of the class. So if you have a method, for example, we're not doing this with the protocol, but we want to create this method string by reversing a string, and we want to put it inside of a class because we're not doing a protocol. We could put it in, well, we can't because we can't inherit from string this way, but long story short, if we had another method that we were only using inside of that class implementation, we could put it inside of the class, put a little plus there. Can't be called from main, it's hidden from main, but it will work inside of the class. That was the purpose of that exercise. However, it's confusing. So it kind of just, if you do it, great. If you don't do it, don't worry about it. You could just say, hey, you know what? It's impossible to make a private method. And actually, it really isn't private. You can still get to that method. It doesn't work the same as it does in other languages. But this one is private. It's not really private. It's not part of the instances of objects. Instead, this is run by the class level. So anything class level is exposed at the class level. Which is why we have a plus there. All right, so back to the instructions here. Save the file. All right, well, in the old days we actually had to save the file. I'm going to go ahead and save it anyway. So the .h file is now saved, which means we're probably going to move on to the .m file, which is going to be the implementation file. Well, let's implement this method to reverse the string. So add the method here. I'm going to cut and paste it and talk about it once I get it in because it'll be color-coded at this point. This is the method implementation that we're going to add to the body of NSString plus add methods in the .m file. So I'm going to cut this here. And we're returning a string from a string. I'm going to copy it and paste it if I can. Here we go. I don't know why I'm having problems here. This is the .m file. I'm pasting it in here. And reverse string. It's going to have a problem with these special characters here because of my cut and paste job. So I'm going to go like this and get rid of that from the PowerPoint or whatever it was. And apparently I think I probably have 2 ends at the end maybe. So I'm going to get rid of this end here. If I go further down, nope, I don't have enough. Maybe I left out a probably a returning bracket, and now I have to put the @end back end. Now all my errors have gone away, which is what you're going to hopefully do in a few minutes. Hopefully, get it all error free. Let's take a look at the code. Stuff we've all been familiar with already. We're creating character arrays. We have 2 character arrays. Where's the TA for this course? Would you do me a huge favor? Could you tell this guy not to play basketball right now? All right. So what we have then is our variable declarations, and we have an NSString object called a return value, a return retrieval string that's going to come out of here. We know from our methods that we know how to create so far. We have a colon and we have one that's going to be a type string. So the method, when we call it, it's going to take a string and it's going to return a string. So we're going to take a string and return a string. And the strings, because they're NS objects, are always pointers. So we have the pointer here for our string. And we're going to run from string, which is the string that we're taking in from the command line. We're going to get the C string from that. We're going to convert it to a C string. And then we're going to get the maximum length of it. And then we're going to, so we can know how many characters are in there. We're going to take a string, we're going to copy it into a character array. That's going to be our starting array. And then we're going to take a loop through, here's our loop right here. Take that character array and go and copy it in reverse order into another string. Take the finished character array and copy it back to a string object and return it from the method. Only thing we're doing. We're just taking a string representing. Why are we going to do that? It's a little easier to create a character array. Same thing as in C or C++. Character arrays and strings are pretty much the same concept, or implemented very similar as character arrays. So that works. So it's kind of not so creative, and it's actually using a printf here, which is going to be a C function. So it's not quite the best in terms of programming examples, but it works. It achieves the implementation correctly. You can probably write a better reversal method. Probably going to still have to convert it to character arrays in order to accomplish that. But that's what our method is going to do. So let's take a look here then. So it's much easier to index it, and this is going to be an explanation of what I just told you, but it's going to be much easier to index it into a C string and build them up from character by character than it is to work with it as an NS object, because we could take the memory address and manipulate it, but it's just so much easier. So the method takes 2 buffers, character arrays, gets the C string representation of it, finds the length, it does a loop to the maximum length of the string, how many characters there are, and reverses it. And the method maximum length here must be one of the number of bytes to account, one more byte to account for the null character at the end of the C string. So we're considering the null character. And then we're going to copy each character into the new C string and reversing the order. And after doing so, we're going to put the null character at the end and then create the new value. So I forgot to point that out. Here it is. There actually, that was that line I had to change because of the character syntax. We actually take that character array, put the null character at the end of it, so we know we're in the end of that. So we can, when we convert it back to a string, we can use it like a string. So, and this is a string here, and a string method that we're going to run string with C string to take the C string and to convert it back. We saw these methods last week actually with the calculator program. So a string, I think we did a string with a float, a string with a double, and we created it so that we could put it out onto the, or use it for calculation. In fact, we probably went in the reverse order. We took the string and converted it to an integer from a string. So it's the same method, it's the same concept being used all over again. So now we're going to add into the viewController.h, which is going to be controlling our review. We're going to import the category so we can use it. We also have to wire the connections. We haven't done that yet. So I'm just going to copy this because I'm a terrible typist. And I'm going to put this on top of the viewController.h file. So back in Xcode, I'm going to click on the viewController.h. We're going to be using AppDelegate actually later today. So we'll see what that's about. So now I'm in the view controller.h, and at the top here I'm going to import the, because I'm going to use that method, I'm going to import the NS added methods. It's the same import, just the same way as you did a protocol, just the same way as you're going to do another class that you're going to create. And after I've put the method in here, I'm going to wire the buttons. And I'm checking here, I want one to be output, so they're going to be a property for the label. It's going to be an, a UI label output. And then the other one is going to be input done on the text field to the did. We're going to put the text field here to wire it to the did end on exit. Let me show you how to do that. So click on the Xib file. Brings up the little screen over here. Click on the little editor tuxedo up here. We've done this many times, so hopefully we're familiar with this process. And make sure you got the .h file up here. And in here, I'm going to take this guy, and I'm going to control drag him down here. I'm going to make a property out of him, and he's a UI label. And what was this thing supposed to be called? Output. So I'm going to call him output. Output. And I'm going to press return or connect here. So now I have a property, and I'm calling this property output. I'll synthesize it in a few minutes. And then on the text, we don't really have to do anything with the text. We don't really have to communicate with it outside of the person pressing return when we're done. And when we're done, we're going to use that method to take the string that's in the box and reverse it. So I'm going to right mouse click on this. And towards the top, you see where it says did end on exit. It's an IB action that's associated with the text box and some of the other components, not all of them, but it is associated with the text box. And I'm going to label this one input done. We call it input done. It's an IB action. And this one's going to be called input done. So let me go back here. Input done. And I'm going to change the type. See, now I'm going back to that ID type. So ID is used as a default data type for everything. You can leave it on ID. I always have a habit of changing it to what it really is. It's a UI text field. I do that because in here it'll say UI text field instead of ID. And then, because for some strange reason, when I look at this, I go UI label, UI text field. I can remember what those items are without having to go like this and figure out what they are from the interface. If it's ID, it's kind of generic. But if we had an ID that was a label, ID that was also a text box, and they all had the same method associated with them, I could treat them interchangeably if they were all ID, but I'm not going to do that yet. I'm just going to use it as a text field, so I'm going to leave it alone. So we're going to switch over to the .m, and we're going to synthesize the output because we're going to want to use it. So I'm going to click on the .m. I usually get rid of this little thing on the top here, the interface, because I don't use it. If we wanted to create something that was just had exposure to the .m, we could put it in there. Not going to bother with it. Instead, under here, right at the top, right underneath add implements, I'm going to put in here at synthesize. And I'm going to put in here, what was it called? Terrible memory. Output. Output. There we go. Now I synthesize output. If I don't put this in here, I'm going to show you this in another. I'm going to show you this in another example. If I don't synthesize it, I automatically get this. I automatically get the underscore output. And then I can use it. If I don't take this line out completely, I can use it like this. I don't prefer doing that though, but you might prefer doing that. Well, one of the things we're going to be doing probably in the iOS class later today is that I do have a project that doesn't do that. It's kind of the newer way of doing it. It's a newer project actually. So here we go, synthesize the output, so I can look at output inside of the .m, creates the setters and the getters for me, if you aren't familiar with that. So now I'm going to add the method body to the input done method so that I can convert the string. So I'm just going to cut and paste this method body here, or copy and paste the method body. And lo and behold, on the bottom it says input done on the bottom here. I'm going to paste it in here. And no problems this time. Okay, very good. So what are we doing here? We're going self output, input.text, which is the attribute that's associated with the output for the text that's going to appear on this label. This is the text attribute. It's going to be equal to the NS string, run the method. And the method we're running is string by reversing a string. And we're sending it the text, which is a string. It's going to be equal to NSLog is going to print out something for us. And then we're going to take the sender. We can also put the word output. We could put output here because that's really the sender. And output's, excuse me, the name of the box here, which is input done, but it's not, we didn't actually put a name on the box. That's why we're using sender. If we make a property out of the text box, we could put the text box name in there. Does everybody see that? We didn't make a property out of it, so we can't call it directly. Instead, we're just calling it the sender, which is its generic behavior that's coming out of that. So if you don't get that, catch me now. Otherwise, I'm going to continue on. Okay. But normally we would see, my text box space resign first responder. Resign first responder is getting rid of that pesky keyboard. Because sometimes the keyboard just takes up the whole space and we can't see anything underneath it. One way of doing it. Another way of doing it is to put in a touch event. So when you touch the background, or you click on the background of the view, it will resign the first responder as well. So if you don't put it on a touch event, normally you're going to put it in a method like this, and you're going to be done. So let's take a look at the instructions. I believe that was probably this last step here. What happened? The action method sets the output labels text property through the reverse contents of the string text from the text property using the string by reverse string method that we just added to the string and a string class. After doing this, the method calls the first responder and gets rid of the keyboard. That's what our program output's supposed to look like. Let's see if it works. So go ahead and run your program at this point. Make sure I have put mine on the iPhone simulator. It should take the string that's coming from the output box and pass it to the string by reverse string method. And the reverse is going to return the reverse of that string after it took and dissected it into a character array and then took and switched the character array into another character array and then copied it back to a string, which not a bad way actually. There's probably a better way, but it's not too bad. So I'm going to type in here. When I type in here, I see this keyboard come up. If I press return on the keyboard goes, return in the box. Well, now I just changed it to nothing. So if I type in, here is my test. This is just a test. Well, this is just a test. I made the font bigger. So if I put a smaller string in here, like hello world, now we see it actually kind of works. So that's what a category is doing for us in this particular example. And the category now, we could take this, we have this actually, we have this out in our project file. So leave that up for a few minutes. Our project file is out here. I called it category. We don't need the whole project over again if we put it as we did. We just take this one and we add it to a new project. We include the header file, and then lo and behold, we have extended the functionality of an NS string to include a method that never existed before, and the method in this particular case is to reverse the string, and we see that in the code when we look at the implementation of it. So in the view controller.m, let me get rid of this side piece. Hold on a second. Get rid of all these views. No, I want that view. I want this view. There we go. So this is an NS string. We're running the method on the NS string. Method doesn't exist in the NS string class. We added that method to the NS string class with the category that we created. So if we want there to be one to reverse the string, we just add it.
But, how will I know that you have created some method like this and I can utilize it?
If you pick up somebody else's code and you're looking at the project and you're wondering, well, where is this coming from? The key is to look at the header. or excuse me, look at the imports of the header files. And if you see something that looks like this, that says NS string, this is why it's labeled this way. NS string plus. So everything that you inherit from NS string or you add to NS string is going to go NS string plus. So it might say NS integer plus. And in the NS integer, we have a method that someone put in there to, I don't know, round integers a different way or something. Round up all that, and the method's called round up. So when someone's running on an integer, round up. Whoa, what is that? You know, that method doesn't exist. That's how you're going to know it was put in there. Or you're going to look over here, and you're going to see this. So if you want to use this again, so you want to make a, I don't know if this has any functionality to you at all, but you take those two files, you drag them, put them into the project, and you import the NS string, and you use it whenever. It's just like importing in IOStream or NS string or any of the other built. Well, you have those built in for you already, but it's just as if you're importing in any library that's built in, and you're basically complementing the functionality. Now, you can still use the rest of the string functionality as well, as we've seen in that example, actually. So it doesn't remove anything. It just, and that's why I said it, I don't know what to call it, it's an enhancement. You came up with a good word for it. It enhances the functionality, because we're not overriding it, we're not overloading it, we're adding to it. So we're adding something that didn't exist to make it more customized for us. So the conclusion of that particular, this is kind of twofold, it's a tutorial lecture. So, there's very useful tools for adding functionality to existing classes. We've added the category to the class. All the child classes of that class will also inherit the added methods as well. Same as the protocols. And that answers your question from earlier as well. It's the same thing that happens with the protocols. And as a future exercise, try to add another method to the NS string category to define maybe that replaces all the strings, spaces in a string with an underscore or something else. Might be handy. Let's say, for example, well, if you stick around for the iOS lecture that comes next, we're going to be using databases and core data and files today. So you could take a string, create a category that parses the string for you, that takes out certain segments of it and does something with it, and then you just run it on the string, and the string is going to come in from a file, or the string is going to come in from user input or something. And then you can automate that behavior a little bit more. Alright, so that was reversing a string. You can go ahead and save or destroy that project. It's all done. So we got 2 down. The next project, we got choices. We could see text views. Yeah, let's look at that. Let's look at R. We could see toolbars. Toolbars is designed to show you more information on how to put in new classes. We're going to add Navigator classes. Now let's just do toolbars. There we go. We'll do two because this is a fun project as well. This is also an iOS development project. So I'm going to go ahead and open this one up then. The classes we're going to actually add are going to be the navigational classes. This one, believe it or not, comes in handy for the iOS people as well. But it really involves kind of an understanding of classes and adding built-in classes, and you're going to use those classes. So the UI Navigator Controller maintains the UI toolbar, which is, you know, at the top of the screen, the bottom of the screen. We've got this little bar that goes across. We can put buttons on the bar. We can have the bars appear or disappear. We can add them programmatically, which is what we're going to do in this exercise here, or we can drag and drop them and stick them on the canvas. If we do that, we still have to link it up with a property and then use it as an object. So it's the same concept. Toolbar is normally hidden, but we can place buttons on it and display it at any time we want. So let's see, we're going to open up another single view application, start Xcode, choose the create a new Xcode project, single view application again, using, don't use a storyboard, same as before. Select iPhone as the app type, only because the toolbars are easier to see on the iPhone. So let's see, create a new Xcode application, single view application, next, and this one's going to be called my toolbar. I'm going to call it my toolbars. There is no finished project template for this one either, so the category didn't have it. In fact, I probably should just save these and upload them, but wouldn't be worth the exercise if you could just download the finished product. Alright, iPhone is the type, use automatic reference counting. I'm not going to use the storyboard. Next, go ahead and click on Create. And lo and behold, we have yet another iPhone application that we've created. And we've got an Xib file, and the Xib file doesn't have any toolbars on it. Doesn't have anything. We actually have it down here. If we type in Navigator, don't do this, but there are some Navigator bar things, but it would defeat our learning experience to drag them over. We could drag them over. We can't do as much with them though. And then we have it outside of the view. What if we're going to use this view for use this window for multiple views? And then we don't have the same flexibility. See, people love to just drag and drop and stick stuff on here, right? Which is what we've been doing so far, but in the intermediate section. I'm trying to make it a little bit more universal so we can swap the interface out. If we drag and drop it on here, we're going to do the same thing for an iPad. If we're using the storyboard, we get the storyboard iPad, we get the storyboard for the iPad, we get the storyboard for the iPhone. If we do it programmatically, we just attach it to all of the interfaces, and we have one set of code that works on all of it, which is a little bit more universal is what I mean by that. And a little bit easier, a little bit harder, it's more advanced, it's not really hard, it's intermediate level. Okay, so we got this far, we opened up the project. Plus we wouldn't have the experience of adding new classes. So we're going to add a new class. We're going to select the Objective-C class template. Then we're going to click on Next, and we're going to name the class Main View Controller. Make sure the class is a subclass of the UI View Controller. And also create an Xib for the controller's view as shown. So we're going to subclass UI View Controller. We're going to make another view controller. Why? Because I'm trying to show you how you can make multiple view controllers that control multiple windows. We already have a view controller, but let's just make a new one. Because what if we have another screen we want to populate? So go ahead back into Xcode, and this time I'm going to select on my toolbars here, just so it shows up in the same spot. We'll see where it shows up. New file, let's see. This one's going to be an Objective-C class. It's in the iOS section, so I'm going to click on Coca Touch, Objective-C class, and click on Next. And so now it says NS Objects. I don't want that one. I want UI View Controller. So where it says UI Table View Controller, that's going to be another project we're going to do. Extend a table view. We're just going to extend the view controller. We want the, do we want the Xib interface? I think we do, actually. Let's see. Yep, we want the Xib, not targeted for iPad because we're going to do this for an iPhone. Make it a little bit easier. Otherwise, we end up with two of them. We're not going to use it. We could end up with two of them and use the both of them if we wanted to. So UI View Controller with Xib for user interface. Perfect. Click on Next. Go ahead and save it. ViewController.m. Oh, because I called it ViewController.m. So I'm going to cancel this real quick here and go back and change the name. And what was I supposed to change it to? Main View Controller. So I'm going to call it Main View Controller. I'm doing this for another reason as well. We already have View Controller, and our app delegate is calling View Controller. We're going to change the delegate because we're going to add a brand new View Controller to this project. So I'm going to say Main View Controller here. Next. And create. So now I have, same as I started out with. I have viewcontroller.h, viewcontroller.m, xib, viewcontroller.xib. Well, now I have main viewcontroller.h, main viewcontroller.m, and main viewcontroller.xib. What did I do? I just reinvented the wheel. I added another set of what I already had. But I can have one call the other, or I can just replace it completely and not use the other. So let's see. What am I going to do? Let's see, I'm going to edit the app delegate.h. So going back to model view controller, the data model is calling the view, and that's our delegate. So we're going to set up a new navigation controller having a main view controller object as its root view controller, and we're going to add the navigation view controllers to the main view controller. And we're going to tell the app delegate to load this one instead of the view controller, the generic one that we were stuck with to begin with. So we're going to select the app delegate.h file, and then we're going to add two properties for the UI navigation controller and the main view controller as shown in the next slide. So we're going to cut and paste here. So we're going to add the two properties plus the header file. So we're going to open up this file here called appdelegate.h, and I'm going to copy and put this one in first. And then I'm going to put in the two properties here. So let's see. Appdelegate.h. This is what's actually going to start at the beginning, and it's going to load our window. So it's going to import my in-appdelegate.h. Let's just see. Missing terminator character. Well, it probably doesn't like my quotation marks. Yes, it did not like my quotation marks. So, when you cut and paste, unfortunately, that's what you end up having to battle with. And we have two properties now. We're going to put in, I'm probably going to have cut and paste issues with that. We're going to do at property and an at property here. Let's see, copy this one. Oops. And let's see. I'm going to put them in between the interface and the end, which is where we put our properties. And we see two other properties here already. I see UI window and view controller, which was our original view controller. Because appdelegate talks to the other pieces when the program starts. In fact, here's another situation you might run into when programs fail. Is when you've deleted a view controller and you've added a new one, but you didn't update the appdelegate. And the appdelegate is calling the old one that's been deleted because it doesn't know about the new one, or something of that nature, or the appdelegate is confused. What ends up happening is nothing happens till you run the program, and then when you run it, it bombs out and crashes all over the place. Although there's no error messages at all in the source code. It's just the logic that's messed up. So what did I do? I've already have this view controller here. It's a view controller. Now I have the main view controller, which is going to be our root view controller. And I have a UI navigation controller. So the root controller is going to be higher up the hierarchy in terms of the object existence, and it's going to call the subcontrollers. So we're getting into this concept of subviews and subcontrollers that are controlled by navigation controllers. Navigation controllers end up higher up because they're used to bring up the new windows, bring up the new screens, and manipulate the order in which the other views are going to show up. So that's why the table view controllers, navigation controllers, all these different controllers usually sit above the view controller in terms of its implementations. Alright, so we're going to synthesize in the next step here. We're going to first synthesize the two properties here. I'm going to go ahead and use this old syntax of the underscore because the code that I'm going to paste in to add the buttons is going to use the same syntax. So I'm going to go ahead and copy here. I'm going to flip over to the appdelegate.m. Because we've used property, we're going to synthesize now those two controllers that we added. And so I'm now going to flip over to the .m. We're still in appdelegate. Right underneath where it says implementation, I'm going to go ahead and paste them in here. And lo and behold, no error messages, which is good. So now the appdelegate knows about our navigation controller and our root view controller. We're probably going to have to change which one loads. Right now when the project starts up, the view controller, the main view controller alloc is the view controller. So let's see what's going to be next here. Let's see. We're going to edit the appdelegate.m, change the did finish launching with options method. It's only method we're going to be making changes to, leaving the remaining methods in place. So where's this did finish launching with options? It's not going to be application did enter, application will enter, terminate. It's the first one, actually. It's hard to see it. It's did finish launching with options. It's where we see it's of it's either a true or a false, which when it triggers a false, your application dies out. And normally, if you've ever had an app that died out right in the beginning and just doesn't run in the emulator, there's usually a problem with the view controller that you've got set. As I was saying before, either you removed it, or you've got the wrong name, you changed the name of the controller, you did something to it. because this method will return, if it returns false, which means it didn't find the right controller, right from the get-go your app's not going to run. Which means if we run this app right now, we're going to get this view controller because this view controller is what's being set. And let's see what we're going to do. So we're going to change that method, leave the remaining methods in place. Don't remove the entire thing. You see where we've got the main controller here? We could just, in fact, let me just do this actually. I'm going to go ahead and cut and paste the whole thing and put it in. Kind of risky. This is an old example again. What I've done in the more current examples is just give you the code to add to it and change to it. But I'm going to be lazy and just copy and paste it. So I'm taking between the curly brackets here. I'm just going to copy the code. I'm going to remove what's in there and show you what changed. Actually, I can tell you what changed real easily. This highlighted code here changed. And we are going to alloc instead of it. We're going to still alloc the UI window. In fact, here, let me just put this in here and I'll show you what changed. Oops. This is word wrapped. So we're, what are we doing? So this is a lot of code for a new person, but you can probably get a feel for what's happening. When the app first loads, we get the self window. We're going to allocate a new window, and then we're going to put it with a frame. The frame's going to be the UI screen or the main window. So then we're going to override the point of the application load here by loading our main view controller. So without this change, it says view controller in here. Now it says main view controller instead. This is the same code as before. We can go back through and change all instances of view controller and add main to it, or you can just cut and paste and put the code in, accomplish the same thing. It's the same code. We're going to also call in and make an instance, so this should be a new line here. So root view controller, because we have a root view controller as well that we're going to use. We have two new instances of new controllers that we've added. And this one's going to be called main view. And let me put another line return in here. Now the navigation controller, we're also going to make an alloc on that, make a new navigation controller. Those are the two controllers. Oops, there we go. I have some extra spaces in here. There we go, much better, much cleaner looking. Those are the two controllers that we added, if you remember, we added as properties, and they're synthesized up here, the navigation controller and the root view controller, which is why I left those underscores in there, because that's how they're going to be referred in terms of their automatic synthesization. But we actually could pull it out because I'm not using it in here anyway. So long story short, would have worked either way. We also have adding the navigation controller to the window, setting the background color to white, and then the window, making the key and making it visible, essentially. Making it accept input, making it visible. This is the default behavior. Nobody ever has to write it. It's given for us automatically when we create a brand new project. And all it's doing is just specifying which view controller is going to come first. And then that view controller can call other view controllers, which is what we're going to see in our more intermediate projects. And then it's also going to add our navigation bar. And it's going to put one on the top. I believe it's also going to put one on the bottom here of the screen. And then we're going to have buttons on the navigation bar. They're going to control like the background color or something very simple. And we're going to call this root controller main view. I don't know, for lack of better originality. So that's all we have to change in the app delegate. And all we're doing is we're changing the launch of the application, so the did finish launch with options. And it's kind of like the view controller did finish. If we look at the old code for the view controller, we have view did load. It's equivalent to that, but it's the app delegate saying the app finished loading with the options, and what were the options? Which view controller to load, which is what we're sending it. So that, if you go out online and read about the app delegate, and the delegate, that would actually merit, that would actually pay off for you. Do a little bit of textbook reading on that one. So what are we doing? First we allocated and initialized the root view controller. The name of the nil in this case directs the compiler to associate the view controller with the Xib file for its main view controller, which is what we did. Bundle nil directs the compile to use the applications bundle, which we did. That's why I said the reading would probably help you understand that a little bit better. After we initialize controller, we set the title to main view. This title will appear in the navigation bar for the view controller. So we programmatically added the navigation bar. Now we can put the objects on. So next we'll set up the navigation controller object. So we're going to make a root view controller, make the root view controller this object's root view controller, adding the navigation controller's view to the main window as a subview. This is all one line of code. And then make the main window key invisible, and then we're off and running. Okay, so it's not too bad. So here's our main view controller.xib. Change the color of it just because we want to tell which one's running actually. So then we can easily this is actually not a bad thing to do actually. Just I know I say I always change mine to green. I do that because when I load it, at least I know the right one loaded. Because what ends up happening is you'll get this blank white screen. And you go, what view controller is that? What XIB file is loaded? I have no idea. But this is the one I want to load, so if it comes up green, I know I've at least got the right view controller loaded. You may have different techniques. Alright, so what do we do here? So we just change background color. So the at main view, actually, I think we could probably run this project at this point. We're going to see that green screen come up. Let me just make sure. I should have stuck in there. I should have stuck in there something about running it. Then we changed the background color, but we didn't run it. So. Green screen. Alright, and I know I have my main view, which is the navigation controller that I added to it. Not a bad idea at this point. If I revise this, I will probably put this step in here. Run it, make sure you get the background. So I can tell this is green and it's not this white one. It's not this one over here, which is white. If I wanted to right now, I could remove these files, no problem, not using them. Or I can just leave them in there because who knows, I might want another view controller, another XIB for something I'm going to go to, perhaps. You know, another menu or something. So now I'm going to close it. At this point I see my main view controller. Main view is coming from that app delegate. When we put the controller on there, I can change it to something else. Change the wording to something else. Alright, so let's go back to the instructions. So that should be added in here. Because I have it here, but I don't have anything that says run it. Or it says we're off and running, but I'll add something in here to run it. Alright, so since the view controller's title property was set to main view, and the app title is going to appear at the top of the interface when we run the app. So now we're going to open up the main view controller.m, open up the view controller.m, and then make the additions to the init with nib name bundle. So let's take a look at this one here. The main view controller.m has it right at the top, init with nib name. So the nib is the interface. It's the controller for the view. They called them nibs. I don't actually know why. However, I can probably Google it real quickly. But anyway, long story short, is we're calling it the controller for the navigation for the view. It's the nib file. It comes from the old days when these used to be called nibs instead of XIBs, interface builders. And we had nib files that we created for the UI, for the interface. So it's going to init with the nib name, so we're going to open it up with the view controller, main view controller. And so we're going to init with the name itself, and inside of the bundle we're going to do some stuff to it. And then this is the method here. When we initialize this view controller, we want to add some stuff to it. We're going to add some buttons and stuff to it so it does stuff. So I made some room down here so I can make sure I've got the right one here. And this is the nib bundle or nil. Let me just make sure. Yep, okay, it hasn't changed. This is a very old tutorial, so it hasn't changed, which is good. So I'm going to cut, paste, and then talk about it in a few minutes as I clean it up. There is a small little closing bracket down here, but I don't need that one. So let's see what this is going to do. Well, I can tell you what, it's going to add a UI button. So it's going to add a UI bar button to the Navigator's right bar button array. Button will be placed at the top right hand side of the navigation bar next to the 3-button bar. We're going to have button red, button blue, and button green, and a spacer. I'll show you the code in a few minutes. The 3 buttons will have a selector, and these will be defined shortly. We're going to have, when you press the button, it's going to run some code that's associated with the button, very similar to how we put buttons on views at this point. Each is also initialized with a title and a style, and the UI button style is style done, which is, will produce a button with a blue background and a white bolded text that's associated with it. So let's take a look at, I'm going to paste the code in here. I'm going to get rid of what's here already. So I have an empty method. Make some spaces so I don't accidentally. Alright, now let's clean it up. And I'll talk about it as I'm cleaning it up. This is actually, believe it or not, the same line of code that happened in the beginning here. We're going to run this super, if you remember from object orientation. First thing we're going to do is run the super init name, same method from the object that called us. So we're going to set our own hierarchy. Then we're going to set up the navigation bar button. This is going to be the button show. We're going to call it button show, which is going to be the navigation bar item that we're going to allocate here. And we're going to allocate it with a certain button style. It's going to be a search, system item search. And the target is going to be self, which means it's going to send events to itself. The action is going to be a selector for the toggle toolbar. And it's going to be put on the navigation as a navigation item, and the navigation item is going to be on the right-hand side. So I've got some extra code, it looks like I've got in here. Let me just put a line return in here. Self.navigation item, as I have accidentally removed things I'm putting back. And then there's going to be an NS array here, and the NS array is going to have an array of objects. Why am I going to do an array of objects here? Because it's only expecting one button to appear on the right-hand side of the navigation bar. And if we want one button to appear there, then we don't need an array. If we want to put multiple buttons there, which is what we're going to do, then we need an array so that we can put them all in an array as an object on there, because it only wants to take one object. So then we're going to set up the bar buttons here. We have 3 bar buttons that we're going to put on here. We're going to have a red, a blue bar button here. And what do we got going on here? We are going to initialize the bar button selection item with a UR item flexible. Oops. Let's see. Let me get rid of the extra spaces here. Say that one more time.
No, there's a space between SP and AC. I guess that would be.
Oh, there's also a space here, but I think there's supposed to be a semicolon at the end of this one here. Ah, okay. I'm not going to get it to come over to the left. The spacing is a little bit messed up because of my cut and paste job. Or, you know what, I should be able to. Let's see. Ah, here we go. Ah, there we go. I got it over a little bit. Anyway. What are we going to here? Okay, so we're creating an array of buttons. We're assigning the buttons labels, blue and green, and blue, red, and green. We're taking the buttons and that are inside of the array, taking the array, adding it to the navigation controller, setting it to go on the right-hand side. And then we're going to select the action selector to these methods that we're going to call them. The methods are going to be blue, red, button blue touched, button red touched, and button green touched. Which means we're going to, after, it's almost like, well, it is event-driven programming, and it's like setting action listeners from other languages, from GUI events where you have event handlers and you have button listeners and action listeners. It actually is kind of the same concept. We're setting a listener on the button, so when the button is pressed, it's going to run these methods, and we're going to paste those methods in a few minutes. And the methods are going to change the background color, essentially. So it's not really going to do very much. I'm going to get rid of the spaces here. what we're doing is essentially just setting the different properties of the navigator so that we'll, what does it not like down here? Maybe an extra. Let's see. Probably going to tell me that control reaches end of non-void function. Let's see what I had at the end of this guy. Perhaps there's a return down here? No, it's the end of that function that's cut off. Oops. Not a problem. We will figure out what was supposed to be on the bottom of that by looking at we're not going to be able to get that, are we? Use of undeclared identifier. No. Okay, so it's because this guy isn't ending correctly. He's supposed to return something, but let's see what it's supposed to return. And the code is a cutoff, so let me.
There's a return self.
Return self.
Yeah.
I was going to say, I was going to open up another project and look at a generic return to see what it's supposed to return because I can't remember. Return self, it makes a lot more sense, and it should go right here actually.
Oh.
Yes, return self. Well, it's an initializer, but nib bundle returns ID. It doesn't really tell us what it's supposed to return. Okay, it's a generic self object. All right, well, I believe that is correct. Is that what your original said? The original has it on there. Okay, yeah. Okay, so yeah, it was cut off on the end of this conversion here. So the function spacer is to be added for the flexible space, and that's the function we called here. Didn't really talk about it, but there's a spacer method being called in here. I can find spacer. Here it is, spacer, which is going to put a blank space in between the buttons, and we've added the object to the button array. So we have an array of buttons, and in the button array we have a spacer object that goes in between. Otherwise the buttons are going to be like back to back with each other. So we put a one space in there, which is how that ended up in the button array. So we have to implement the spacer. So the function of the spacer is to add the flexible space between the blue button and the green button so they're not back to back. Flexible spaces will act as a spring between the two buttons, pushing the green button all the way to the right of the toolbar. And since the space is invisible, it makes no sense to assign it an action method, so we have to set that one to null. So now we have the buttons, and we need to add them to the toolbar. So each view controller has its own toolbar button property associated with it, which is an array, and this array of buttons, themselves button objects. So we stuff the toolbar array with the 3 buttons and the spacer, which is what we did to it actually. That was already done in the code. So the last step, we're going to need to add the method bodies for the what happens when you press the red, the green, and the blue buttons. So we're going to add the method bodies. So implement the 4 methods as set as the actions for the buttons as shown in the code below. The next slide. This one here, I can probably easily just cut and paste one of them because they're all the same, and then just change the code. But for our toggle toolbar, actually I need to do that one. In fact, here I'll just do this. Dangerous, I know, but let's just do it this way. That's why I switched instead of PowerPoint and started putting them into PDF files. This is one of the original ones I haven't converted yet. So I'm going to stick it right underneath, this is in the view controller, and I'm going to stick it right underneath this method only because then I can find it more easily. And that actually cut and pasted, not too bad. So the bar state is going to be, which one did we look at? It's going to hide the bar. once we click on it. And so we're going to set the toolbar hidden to the, not the bar state. So if the bar state is not active, it will be hidden. And then the code here is the same code that we've used in other examples for, let's say, for example, the background color or the UI color is going to be color red. We're just using the built-in colors for this. And the blue button is going to, well, it's not really blue, it's going to take it to cyan. And then the green button is going to change it to green. So our buttons are now added. So let's take a look here to make sure there's nothing else. I believe we're done at this point. So the toolbar gets the hidden property of the toolbar when it's set to the property, so it's to its navigation. So in other words, the toolbar is hidden. It will be shown if it's shown. It will be hidden if it's not hidden. And then we have the 3 buttons, and you'll see the functionality in a few minutes when you click on the hide. So touch methods set the color of the background to red, cyan, or blue when it's touched. So the program output should look like this, where we've got the main view, then we've got the toolbar. It shows up on the bottom. We're going to hide and show it, or we're going to have the different colors that we can press. So if the project at this point should be runnable, so if we run it, this is actually kind of a test to make sure that all of the code still works, although I do need to edit that one slide. Let's see. So mine is green, and I have no toolbars on the bottom until I do this, which is going to hide and show. So this is really the search, and we added a search bar button here, you know, for lack of creativity. We could have put another button up here instead of calling it a search bar button and called it hide and show. But it's showing you how you can actually add one of the built-in buttons. There's also one that says done on it. There's one that says edit on it as well. We put it on the right-hand side. We could very easily have put it on the left-hand side by changing the method body. So if we press on a red, we should get red, blue, blue, green, green. Cyan, here's the blue. This is cyan, not really blue, but or red, and then we have the hide and show. So what we did is essentially run through the drill of looking at the app delegate, getting the app delegate to run our own custom view controller. On our custom view controller, we added a navigation view. Actually, we added 2 navigation view controllers along with button bars, button array. So the space is what we're looking at here. This is the space that was talked about. Without this space, if we take this space out, these buttons would be back to back, which is going to cause a problem, especially for bigger fingers touching the buttons. Might not necessarily catch the right button. There's no built-in functionality to actually add a space at this point. We could adjust. In fact, if you want to play around with this further, you can put some of these buttons on the top if you want to. Make that into a custom button instead of it being a search button. And then maybe play around with some of the other. I can't do it on this because I don't have it on a device, but you can get the swipe control, the gestures. And we'll have a full lecture on gestures coming up, actually. It's an intermediate kind of concept. You can get the gestures to pull up that bottom navigator, which is more common. Most applications just swipe up and it shows up. And sometimes it pulls up all the way. And you can add a lot of stuff to that, like instructions and things. So, all right, moving right along. Any questions on this one before we continue? The next one's actually not too bad. I still got some time. We still got a half hour, so we're still good. This one is pretty done. This one's pretty done. So I guess we're going to get to introspection. This table view is a little bit too long to do today, so we'll do the introspect. Introspect is actually pretty easy. It's about nesting items inside of items. It's not too bad, actually. The learning objective of this particular tutorial is to get you so you're not afraid of adding stuff, subviews and views, and putting things inside of containers and objects. And it talks about dynamic binding. So, Objective C, what allows us to dynamically bind. So the feature makes it possible to postpone the decisions about which class we are going to be dealing with until later on in time. So we can put a bunch, and this is where we're actually going to use ID for the components. So it makes sense because then we don't know if we're looking at a toolbar, we're looking at a text, a label. If it's all ID, we can dynamically just put it there. And we can use it as an object. So we're going to make this kind of decision, however, we need to be able to determine exactly what classes or classes we're dealing with. So we're going to basically make subclasses and stick stuff inside of classes and selectively open and close different classes and objects. So I create a brand new Xcode project and select a single view application. In fact, I think I'm going to keep those two projects because I didn't have any finished ones. So my toolbars and category, I have to make sure I keep those actually. And then convert that into a into a PDF. I believe we're going to do single view again. Single view and use the automatic reference counting, don't use the storyboard, don't really need it, and select iPhone as the type. And then we're going to create an interface. And we're going to use a view actually for this. So let's see, I'm going to call this one introspect. And I don't have a finished product for this one either, so here it is, introspect. And it's going to be iPhone, use automatic reference counting, and go ahead and click on next. And I'm going to go kind of fast through this because we've done this so many times. So. And we have our new project. And look at that, we have another Xib file. I'm going to open up the Xib file. And what am I going to do here? I'm going to drag a view from the library to the window. A view. And then I'm going to put 8 labels into the view. And you should have a large white space, which is a UI view object containing 8 labels. All other controls are on the main view. So it helps now to be able to look at the hierarchy of items on the window that we're looking at. So we're going to have a view, and then we're going to have a view inside of the view. So in here, we already have a view. If I go down to the bottom, I see this little thing here we haven't been using yet. So this is an introduction to this tool down here. We see the hierarchy. We have a view here. Down here in the library, I can type in view. I can add another view, which is going to be a subview. Or if I just say UI view, hold on a second. Here's a view. I just want the view. So last time we put a scroll view on there, we've put image views on there, we've put tab views, table views, maybe. I don't know if we've done that yet. I just want a view. So I'm going to put a white view on here. And then over here I see view, and then I see another view. I can selectively load views. Why one view controller? What are the views? Well, interesting. It's, and I'm going to use this expression with caution, but it's the poor man's storyboard. So the storyboard came out, and now we have multiple windows, and we can have the navigation control between the windows and between. In the old days, you just put view on top of view on top of view on top of view. That's why I call it the poor man's storyboard. And you wanted to change the window, you just switch the view. Unload this view, load this view, load this view. Oh no, load that view, load this. But it was all under the same controller, kind of like the storyboard. But if you imagine what's going to happen if I start adding another view, another view, another view, for each one of the screens of my application is going to show up in a different view. This gets a little bit complicated to look at. It's ugly, actually, very ugly. The storyboard's a much better option for this. Because each one of us is on its own separate little window, and you can see and you can control the navigation between. Storyboard allows you to control the navigation between which view is going to call another view, which is going to call another view, which is going to call another view. And they're all controlled together by the same view controller, which is why when we select the storyboard option, we only have one set of view controllers. Same thing as before, but here we have the Xib file. So I say it doesn't really matter if we do single view or storyboard, we're going to get the same thing. But inside the view, add 1, 2, 3, 4, 5, 6, 7, 8 labels. So drag some labels, make sure you're putting them inside of the view. So type in UI view, drag a view over, and then I'm going to go here, label. And I can actually make this view a little bit smaller if I want to. It doesn't have to take up the entire space. There we go. In fact, I'm going to want to make it smaller because I'm going to put stuff on both of the views. So I'm going to get 1, 2, 6, kind of like our calculator. I guess I can cut and paste. 6, 7, 8. Now I got 8 labels in here. And I see the 8 labels inside of this view, and this view is inside of that view. So we're working with the nesting. What else am I going to add? 4 buttons. I'm going to put the 4 buttons. If I were able to close this, I'd see I'd put the label and the 4 buttons on the outer view. So the way I'm going to be able to tell these apart again is to make this background, my favorite color. There we go. Or some shade of it. There we go. That way I can tell the inner view from the outer view. And then I'm going to put a label out here. And I'll just put here the application. There we go. And then I got, 4 buttons? Let me put this view up here a little bit. It can't be 4 buttons. Is it seriously 4 buttons? It is 4 buttons. Test 1, 2, 3, and 4. So let's see, button. You can just put a UI button out there. Actually, this view can be made a little bit smaller. We don't have to necessarily, it doesn't have to be this big. There we go. This is test 1. Test 2. Test 3. Hope you guys are doing this. Go ahead and drag 4 buttons out there. Test 4. Obviously the buttons are going to control the views for us. The buttons can hide a view, can load a view, and again this is called a poor man's navigation from a poor man's storyboard. Multiple views stuffed inside a one window frame kind of concept. It does come in handy, however, for certain things when you just have like a lightweight kind of window you want to throw up there. Or it comes in handy for this purpose. We have a view inside of a view, we have subviews, we can control this whole view in one shot. So let's say we had preferences that showed up when the person clicked on a button, change my preferences. Then the window can show up, cover up the rest of the screen. No problem. Window should, and then the person presses done and then the window goes away. Why do we want to set another window up for that and another whole view controller? Why do we want to? So this I say is lightweight. Used from very minimal, kind of show preferences, hide preferences, show different things. All right, so let's go back to our instructions here. I think we've got the UI set up correctly. Add items to the UI view controller. Wire them. So we're going to call this test 1 press, test 2 press, test 3 press, and test 4 press. So we're going to put the buttons on there first. They're IB actions. So open up the UI view controller.h file and go ahead and wire the buttons. So I'm going to minimize. I don't need this anymore. I'm going to go ahead and I'm going to close it. And I'm going to press on the editor over here and get rid of this attribute inspector on the side. Make some better real estate on my screen here. So I'm going to right mouse click, and it doesn't really matter. I'm going to which event you push down. I'm going to put down the touchdown event, however. And what am I going to label this thing? Oh, I'm going to still have a UI button on it. I'm going to use a test 1, test 2. Okay, so test 1, test 2. Let's go ahead and label that. Test 1 pressed. And a test 2 pressed. Oops, don't want to do it that way. I want to do it this way. Here we go. Let's do a test 3. And then one more. Okay. So we have our 4 buttons wired. Kind of tedious, but hopefully yours are wired. Maybe at this point. So let's see. Now we're going to be declaring action methods for the 4 buttons. So we're going to get those buttons taken care of first. So what are we going to do? We need to, we don't need the IB outlets in this app. We're going to find controls in the view by inspecting the properties of the objects inside the main view using the introspection. So in here, what we're going to do, we haven't made any properties, by the way, which was the point. I'm going to take the code here, and it's going to be the same for button 1, button 2, looks like button 3. No, it's going to set the text here. Okay, so well, let me just cut and paste them individually. So this is one for the button 1 pressed. So I'm switching over to the .h file. I'm just controlling the buttons right now. In the .h file towards the bottom, I have the button. So button number 1, what's this button going to do? Let's see. I'm just going to do them individually. For UI view of view, for the UI view of view, in self.view, subview, the subview of the self, which it is, if the view is a member of the class UI label, meaning this is a label, which it is, then a view background of the label, set the label background to red. So what we're doing is we're inspecting the view, which is why it's called introspection, actually, by the way. We're inspecting the view. We're not making properties. Notice all I made was the 4 IB actions for the 4 buttons. Some people would be concerned. They're like, well, how come you didn't make any properties and synthesize anything for any of the other components? And we got a ton of components here. Well, because I'm going to introspect them from their object types, and I'm going to treat them, anything that's a UI label, the background color is going to turn to this. So I can take all labels and get rid of them if I wanted to. Because it's going to take a look at the view, find the subview of the self, the subview here, and then if the view, UI view, if it contains, it's a member of the class. So the member of a class is the object type. So this is the same thing that we can do in terms of different object types. We can see if this is, if the fraction is a member of printing. We can see if it's a member of something else. So we know that the object itself, because we don't even have an ID for these objects actually, we're just treating them as generic objects that are on the screen. If it's a member of the UI class, then set the background of the UI, set the background of the view, which is going to be this item here of the UI label. Set the background to red. Alright, so what are we going to do with button number 2? I guess we could have changed the label so it said, you know, I don't know, change the label color. So button number 2 is going to look at the UI view itself. So this is why I made it a color. So I'm going to change the background color of the UI view itself. So for button 2, I'm going to go paste here. So here, actually, I'm going to do this so I know here. Change label background to red. And then button number 2. I'm making an improved version of this. So we know what the buttons are supposed to do. Okay, so button number 2 is going to take, and it looks like it's going to change the UI background so to blue. So if the view is a member of view, so UI view is view, if self subview, if it's a subview, meaning this view here, it's a subview of the main view, then change the background to blue. So I'm going to put here, change the view background to blue. Alright, and then on to number 3. This is why I didn't want to do them all together, because they all do different stuff. Oh, it's going to change the text to hello on the label. Let me get rid of this space right here. Let's make this one number 3. And number 3 is going to do, again, same code as before. The ID of view. So now we're actually going to use the generic ID. the ID of view this time. If it's in self.view.subviews, which is going to be these labels here. A view can perform actions, select text, so it's going to do set text with sender a view, set the text to hello. So I'm going to put here change text to hello. Change text to hello. Whoops. Change text. How about it? UI label text to hello. All right, last but not least, what else are we going to do? Notice we didn't make properties out of any of this stuff, which is the point. So let's see. Last but not least, number 4, and of course it's cut off again, so I might have to figure out how to get the closing brackets to work. Don't believe it's returning anything. This one's going to set the back UI color to green color for the label. I might want to change. I think this is going to be on the subview, so it's already white. Oops, don't need that. Now let's just see if I can get this code finished here. Oh, don't have a 0 at the end, that's for sure. And I believe we might have an extra. Well, now I have to go take a look at my Alright, let's go see what opening bracket here for. Let's just do it this way here. I'm going to need 3 of these at the end here if it's following the same pattern as before. There we go. If UI view of view is in self.view, it's the same thing as before, then opening bracket. If a view is a member of the class UI view class, opening bracket, for UI label, a label in a view, subview, change the label background color to color green. And now I'm going to go trace my opening and closings. So 1, 2, 3, 4. 1, 2, 3. One more. 4. There we go. That should be working. Alright, so I'm going to go see if there's anything else left on here. We're going to add more methods, it looks like. So we're going to have methods to do, probably to show the views. In viewcontroller.m, add the methods immediately after the implementation line, which we did. Run the application and observe the results by pressing each one of the buttons. Alright, so let's see. Let's see if we're working at this point. So I'm going to go ahead and run it. The buttons should actually work. I believe there's another modification done at the bottom of it, but we'll see what's going on. Because I know that it's about... Here we go. Waiting for the emulator to load. Well, we have our auto adjust done, and I have the... This is a classic example of what happens when you take the big iPhone screen and you run it on the little emulator. And you have auto adjust on there. It's going to scroll it down. So change, I don't know what this one was supposed to be, the background color, hello. So we will fix this problem by looking at the view, going into the attribute inspector.
And Barbara, can you
Yes?
step through the lines?
Say that one more time.
Instead of running it completely, can you run it line by line, step through it?
Yeah, you could put breakpoints in. Don't like breakpoints though. Let's see. There's a feature in here to take. Well, here actually we'll just do it this way. Right now, 3.5. Oops. There we go. Just. Well, it doesn't really matter. We have like 6 buttons on here. Actually, let's see if that's going to fix it. Did I not change the label here? Which one? This is going to set background color to blue or something? Hold on one second. This one is going to change background to blue. of something. Let me try it again. There's an auto adjust feature you can pull off of there on the attributes of the window that will adjust that for you. Otherwise, I just changed the size of the view to match the size of the emulator. In this particular case, there's none of the loading of the objects that would actually have an effect on this. It's primarily the, okay, so we got labels underneath. Oh, it's green. Changes the background of these labels. And this is where we've got the hello, this one's supposed to be that background. So the buttons are working, our UI is a little messed up because our view is messed up, because it's auto-adjusting. We need to turn that auto-adjust off and it would actually fix the problem. So, in fact, let me find the auto-adjust. Where is it going to be on the window? Let me just take a few minutes here. I don't remember off the top of my head where it is actually. Unless you know, I'm sure somebody knows. It's on the view object itself, the window objects. User interaction enabled, accessibility. It's called auto adjust window. Auto resize subviews. Let's see. Let's take a look here. That's one of them. There's one on the window itself to auto adjust. What it does is if, let's say for example, you're on a little screen and you go to a bigger one, it can make it bigger and smaller depending upon the type of screen that you're running it on. Well, alright, that didn't quite do it. But you can possibly see that the window, the buttons functionality is working, although the interface is a little bit screwed up. The views themselves, this background view here is being changed appropriately and the buttons are working, even though the UI messed up is auto-viewed. Actually, let me take 1 second, see if I can find it. Use auto layout. Pull that guy off. Use auto layout. It's the one I was looking for. Let's see if that fixes the problem. Generally, when that happens, the first thing I look for is auto anything. Because something is changing it from the way I laid it out and the way it's looking on the screen, which means some auto behavior is appearing. And look at that, it fixed it. Except for I have a label down here that's coming in underneath the view. So I can actually turn it, I turned it off on the big view and didn't turn it off on the little view. So I can see I turned off the auto adjust on the outer view, because I clicked on the outer view. Now I need to click on the inner view and turn off the auto adjust to fix that problem. Where did I find it? I found it in the first screen here. Auto layout. So, oh, should be nested. It's either that or I do this. Just make it smaller. Why do we have a button? Oh, okay. Fix this now. Very perfectionist here for window sizing. Let's see. So I turned it off here. Auto resize. So there's two of them here. They're on the attribute of the window. There's an auto resize, and then on the window itself, there's an auto layout. So this should hopefully yield my recommended or preferred layout, the ones that I actually created here with no auto behavior happening. So I'm running it. Let's see what happens. I have a recording software going on this computer. I still got a problem. I don't know where that label is coming from underneath it, because I got 1, 2, 3, 4, 5, 6, and I got a label underneath. Not quite sure where that's coming from though. So this one just changed the view background to blue. Did. Changed the label background to red. Did. Changed the UI label text to hello. Did. Changed the background. Well, I changed it to green, but the background of the labels. 1, 2, 3, 4, 5, 6, 7. Looks like I put 8 of them there, didn't it? Do I have 8 of them in here? Actually, here. Oh, I do. They're down below. They're shining through. You know what? We'll just do this. I thought I only put 6 of them on there. Now we should have perfect display. Alright, it's because they were hidden underneath. So the first test looks at the subviews of the main view, and it uses the is a member of class as we looked at before on each one of the subviews to determine if it's a UI view. And then the member of is a member of method returns yes if the object instances of one specific class if it belongs to the member of that hierarchy. If so, the method finds the UI label, and then a subview of the main view sets the background color to red. And here's our test 1 button output, as we saw. And the label object itself is inside of the white square UI view. So we're looking at the subview there. So it's because of these white labels, it's a subview of the subview, and not a direct subview of the main view, which is why we got the subview out of that. And the second test looks at the subviews of the main view and descends which ones are going to be the UI view. From that UI view where the label is going to be. And this is accomplished by the, again, is kind of class. Since all the controls are descendants of UI view, this method will change the background color for all the subviews to blue. So the backgrounds are blue. And we actually saw the backgrounds of these turn to blue as well, which is interesting. And again, the background colors of the labels of the internal white square views are unchanged, since the default background for the UI label is transparent, actually. Yeah. We could change that. We could make it non-transparent, and then the background would change, actually, for the labels. And test number 3 searches all of the subviews of the main view, and that has the set text method associated with it. And if it contains the set text, it changes it to hello. So it accomplishes it by using the can perform action method, which is interesting, which I forgot to point out, actually, so we'll take a look at that. So in that last one, instead of looking at is it a member of, or is it does it abide by the class, it runs the can perform action. If it can perform the action, and the action that's going to perform is a set text, then we're going to perform the action, or the action is going to be a view set text. We're going to set the text. So what we're doing here is we're looking at what kind of object is it? What view does it belong to? And can we perform this method on it? Well, all these different various tasks are getting at the object components as objects, as generic objects, treating everything on the screen as a generic object. So we're not really concerned with, you know, the property or the synthesizer or anything associated with working at it through there. But normally we work at it through labels that we give it, through properties that we establish for it. But you don't have to. In fact, this is how you're going to have a view show and a view be visible and view invisible on a subview. So you can actually have things pop in and pop out, or show and not show on button clicks and stuff, which provides you a little bit more custom navigation. Yeah?
The subview is only referring the one which is inside one?
Well, we have two. We have a subview and then we have a sub-subview. This is going to be the subview of window, actually, of the object. So then we have the, this is really, if you want to think of the hierarchy, this is really the subview. And this is the outer view with the subview. And then the subview's got the labels inside.
In the code we are all referring to the subview.
And the code, which one is going to change the little buttons to red? It's view subviews. So of the view, this is the view. This is the subview of the view. This is like, this is the view, this is the subview of the view. It's two different words. One's the view, one's the subview. If we had a subview, we can go view subview dot subview. That actually works, because it's a subview of the view, which is the order of the hierarchy. Which you're going to send up at one particular point, you're going to end up getting extremely confused which one of this is a view of the other view, and then you're going to go storyboard. I'll have to just use a storyboard for that. And then you have all your views are separated out into different windows, and you're just calling a different window, loading a different window with a different view inside of it. However, this makes sense for little stuff. When you don't necessarily want to load up another controller with another view controller with another window and another view and a whole set of everything just to pop up a little. Well, actually, if that were the case, I'd send up a UI alert view. But these are equivalent to alert views in terms of its components, if you think about it. So this one was the one that was called introspect. And I think I'll save my finished product on this one too, because I don't have this one completed. Question? questions on this one? No? Okay, good. Then I've, well, let's see if there's anything left in here. There's more slides left. The rest of this slide set is actually just going to go through what we just looked at. Test 3 button. And looking at the test 4 button, in the subview, the changing the background colors. You can go ahead and read through it, actually, and get a better understanding at a slower pace. So introspection is useful when you have a large number of similar controls and you want to find a particular control by looking at some of the attributes that are associated with control. Like, give me all the buttons, and give me all the labels, and give me all the text or all the views, and hide all the views, which makes sense. So it's useful when you're using inheritance, and you might want all subclasses of some class to perform a method, and but only if that method is defined, and then since set. You might not know what object will be performing the method at compile time, so you can see the introspection. Extremely powerful tool because then you know what's going to happen without, dynamic behavior without knowing exactly which ones you're going to see. So, which is why a lot of people put a lot of stuff on subviews and then just hide the subview, show the subview, enable the subview, disable the subview, and then you can have the entire view sectioned out into subviews if you wanted to make that a little easier. All right, I think that was probably enough for today.
This one is, you were saying, equivalent to a storyboard? That's right.
Well, in a storyboard, let me show you here. Let me show you a storyboard example on steroids, actually.
Or maybe storyboard is more like static.
Let me show you what I mean by this, actually. This is not a bad idea for me to actually show you this. Adventure game storyboard. Let me just save this. This is in the Digital Arts Apps example project. This is storyboard taken to the extreme. Imagine if all of these views are on one window. Well, let me make this a little smaller so you can see what I'm talking about. I made it a little bit smaller so you can see what I'm talking about. We got 1, 2, 3, 4, 5, 6, 7, 8 subviews with different controls. And this is the storyboard. We're going to do one of these. Actually, probably not next week because next week's a holiday. But I can't remember when this comes up, but we have one of these in the makings. So what this is it's got one view that controls another view that controls another view, and they're all through the centralized controller system. So, this is just nothing more. In fact, this is a sloppy example because all of these views are using one view controller. And one view controller with, a lot of different items on there, a lot of little buttons. If I run it, I'll see what it looks like here. Oops, can't run it. Select it on my iOS device, so let's go here. Run it on the iPhone emulator here. Remember those games as a kid, would you like to go? Your plane just crashed in the middle of the forest. You have two choices. Let's see what the choices are. I can't remember actually. I thought we were running. Build succeeded. Give it a few minutes here. Actually, this is a graphic intent, so there's a lot of images and there's audio in here as well. So it does take a little bit longer to build. Digital Arts App, Adventure Game. So I put up a fake splash screen that's a view. So there's one view. Start the game. And then I have the views coming in like up and down, left to right, just to show you transitions. Actually, I think they're all in this example going up and down. So your plane just crashed on an island. Help is coming in 3 days. Try to survive. Do you want to play or exit? If you exit, then everything goes away. The app shuts down. Otherwise, if you play, you can use this button here. It's not on a navigation controller, but it will navigate back to the previous view. All this is a bunch of views. This is about half a dozen views. So with blurry vision, you look into the surroundings, you're lost. So you can either walk or sleep. So I'm gonna sleep. Probably the bad choice. Sleep time. Feel well rested. However, you're hungry and you're freezing without any shelter right now. So it's too dark to build shelter. So now try to fall asleep in a tree, but you're attacked by monkeys. Not a good thing. And so now the end of day 1, you fell asleep beneath the tree. Day 1 has successfully completed. However, your health score is 110. I don't know if that's good or bad right now, actually. So continue, and you continue. You're supposed to go on to day 2, to day 3, to day 4. What it's basically showing you is how you can take, this is extremely simple, by the way. The concept of the storyboard is what's being demonstrated here. You are creating a story in terms of the adventure game, and you're going from one screen to another, and the screens themselves are just views inside of windows. But imagine all this stuck in one little window. And you put a view on top of a view, on top of a view, on top of a view, on top of a view. It's extremely difficult to manage all of that stuff. It is still being, this is the fault of this program actually, it is still being controlled by one view controller. It is technically all one view. They're just different screens of the same view.
So when you have more screen, it's better.
You should, if you're going to do this, you should separate it out into multiple view controllers. Or at least more than one for this. One that maybe does the score. Actually, the app delegate can be used for the scoring probably. Or a database. If you hang out for the next class, we're going to look at databases. So, actually, it's not a bad design. It's just primitive when it comes to app design, but it works. There's nothing wrong with it. It's not sophisticated, but you know, yet again, sometimes simple is better. It's not complex. So. But the point of the issue is I have another version of this where I've taken all the views and stuck it inside of one. And they all kind of overlap with each other. And you gotta, like, if you look at this here, I've got 1, 2, 3, 4, 5, 6. I got multiple boxes. Imagine just one box with all of the stuff in there, and then you're looking at this here going, well, I got a view. And then inside of the view, I got another view, and then I got another view, and then I got another view. It's really hard to navigate through the views. And plus, when you show the view, in this particular case, this came up, so the other one's going to show up on top, and the other one's going to show up on top. So when you load them up, you hide all the other views except for the main view, and then you selectively hide and show views all the way through the code. Not quite as efficient as doing through a storyboard. So, all right, I'll leave you with that, actually. And so we're done for today. Next week is President's Day. The school is closed on Monday. So there is no class for this one or the next one. No Objective-C and no iPhone class. It's a holiday. So enjoy your time off. When we come back, I think, I'm trying to remember the schedule. I think what we're going to be doing is table views, different types of views, table views and controllers and storyboard, and more subclassing, I believe, as well. Putting components on dynamically instead of dragging and dropping them. Using multiple view controllers with one view as well is also on the agenda. Alright, so unless you have any questions, we are finished for today. Okay, well, we have a little break. You can ask me questions as soon as I stop recording.